Okay, so the next function we already have seen is the fit function. And there are multiple reasons why you would need that. The classical reason is why it exists, and that is changing a certain value range to a different value range. And that's usually the case if you have to normalize something. So what does that mean? For example, if we have a grid and we change the size of the grid to something less normalized, so let's say 10 meters in length, in X in this case, then let's say we wanted to, and let's give it a bit more subdivisions so that this makes sense, something like this maybe. And then we say we want to control the height of each point based on its position in X, and we control this with a ramp. So let's say we create a ramp, and this should be driven by the X position of the point. Unfortunately, once again, you can't see it, but this is X, this dimension here is X. But my head is as usual in the way. So if I run this and create actually a ramp, you can see then something annoying is happening. And that is that even though we would maybe expect that this kind of ramp here would control the height along the whole range, it actually only works until 1 meter, and then it repeats itself. So we already know that the ramp expects a normalized input, so this will not work. So we have to prepare the input. Let's call this input, because who needs creativity? And we say, okay, we use the X as an input, and the fit function can be used to change the range of it. So it starts with, in this case actually, -5, and it goes to +5, and this should then be remapped to 0 to 1. And this is a way to remapping the whole range onto a new range that can then be used as a normalized input for our ramp here. There you go. So I think this makes sense. The problem here, of course, is how do I know the minimum and maximum, which is a different topic. There are functions for that. Some of them we've seen, some of them we will see. But for now, let's just accept that this is a very common problem, that we have to actually change the range of values. And of course, one classical example of this we've seen is that we remap the height of a landscape to 0 and 1, and then we can use a color ramp to colorize the points based on their height. So we've seen this example before. But I use this very often for a completely different thing, and that is changing the contrast of something. So let me quickly set this up here, which will be a noise based on the position, but to make it easier to see, I think I will turn it into a black and white version of that. Especially with noise, I have this all the time, that I might not want to change the amplitude or the frequency, but the contrast of the whole thing. And this is not easy to do with the function itself. What I would have to do here, or what I can as a potential way of doing this, is using a fit function. And the way I do that is I remap the minimum input, which is 0 by default, and the maximum input to the 0 and 1 range that I had. So if I set this to 0 and 1, then nothing happens. But if I dial the max down, then everything that is everything that is above 0.5 will turn into 1 or white, and everything below 0.4 will turn to 0 or black. And this is one way of controlling the contrast. It's actually, just one way of doing it, in a little bit of an aggressive way. There are alternatives to that. For example, what happens here is that the max input will directly be set to 1, which means it's a clamp. So nothing can be higher than 1. But sometimes I want something that is not clamped, and this makes more sense when we actually look at it in form of maybe 3D geometry. And you can see it literally clamps, but we could change this to a new range that is not clamped, but is extrapolating further. And this would be an E-fit. And what you can see here, which is a bit harder to control, is instead of clamping it to 1, this basically defines a relationship of ranges, let's call it. So if anything is above 0.5, let's say, then this would be equivalent to 1. But that means that something that would be 1 would then be equivalent to 2. So the same logic applies to the whole range above 1. I hope this makes sense. I mean, this is why I showed it to you, because it's a bit hard to put in words. But this, you could also call this contrast, but it's a non-clamped contrast. By the way, while I talk about contrast, let me show you something else. And that is something that I've seen before. Some people do something that I find interesting, and that is they just use the power function, which means it's an exponential multiplication. So when I say py and 2, that means that py will always be py multiplied by py. Here's the logic, the input, and then the exponent. So this means that this number will be multiplied by itself. And this actually also should give you a higher contrast, but it doesn't for some reason. Oh, of course, because there is no data. I'm an idiot. So let's use a float first, the float noise. So of course, to increase the contrast of something, I need to have a value first. Very clever, Christian. So here we go. Now we have something that comes out of the noise. There it is. And by itself, it looks like this. And if I put an exponential multiplication, then it looks like this. So we do the same, like we increase the nature of the number, something like that. I'm not sure how better to describe it, and this then happens. I don't like this personally, because as you can see, it kind of mushes your result and it gives you very little control. This actually makes a bit more sense when you have negative numbers as well. So let me quickly try this again. If I turn this off, it looks like this. So it's positive and negative. If I then kind of create powers of that, then basically what happens here in my words is what was strong gets stronger and what was low gets lower, because we multiply any number by itself. So if you multiply 2 with 2, you get 4. If you multiply 0.2 with 0.2, you get 0.04. So something smaller gets even smaller and something big gets even bigger. And this is the logic behind the power. So anyway, this is about contrast. So this is one way of doing it. I don't like it. I prefer to have more control over this. And this is why I personally use fit and very rarely efit. But even efit would, in my opinion, be a better solution for this. But I usually use fit because then I can control what the maximum and the minimum is. And here it might look horrible, but in certain cases, this is actually exactly what you want. So this is the whole topic contrast. Then the other thing we can do with this is we can actually change expected results, let's call it. Because we've already seen in the last video that if we, and let's get rid of this, so a fresh grid, that we can use the data type conversion to create random integers, for example. You could, of course, to change the range of your random result, just multiply the result. So for example, like we saw before, we could create a random number here, which will be between 0 and 1. If we turn it into a float, that might be even easier to see. Actually, no, let's put this on a simple float attribute. I think that's good enough. And here you can see the number is between 0 and 1. And if I know that I want maybe the result to be between 0 and 3, then that's pretty easy, because then I just multiply the result by 3. And then my maximum that I will never reach will potentially be 3. And the minimum, like we see here, will potentially be 0, even though I will probably never reach it. But what if I want my range to be between -2 and 3? This is where the fit range function of course comes in as well. So since I know that my input of the random will always be between 0 and 1, I can then remap that to, let's say, -2 and 4. This could be interesting, for example, if you create random p-scale for something, then you can use that to define what the range of the random p-scale will be. There's one small trick to this actually. Since we know that the random function will always give us something between 0 and 1, we can actually save this part and shorten this up, because maybe you've seen that before. If you type in fit, there are actually a couple of 0, 1, 1, 0, and 1, 1, which I explain in a second, functions, which simply save you a little bit of typing time. So the fit 0, 1 just means that the input is already 0 and 1 for the input parts. So if I can then do something like this, so like we just saw actually, so -2 and 5, for example, and I don't explicitly have to tell him that the input is between 0 and 1 because of the name of the function. He expects that already. And as you can see here now, the maximum is 5 and the minimum is -2. Let's quickly look into the help, because the same is true for the other way around, that the minimum is 1 and the maximum is 0. Why do we need that? Because sometimes you want to invert something. It's basically simply for that. I don't need that very often. But what is interesting is the fit 1, 1. And that is when as we talked about, when you have something like an S noise, for example, and you know that the range is not between 0 and 1, but between -1 and 1, then you can use the fit 1, 1, of course, because they couldn't use the minus in here, but this is what it means. So this is kind of interesting and just gives you a little bit more tools in your toolbox. But the most important thing really is that the 3 most common use cases for fit is simply changing the range. So this is often for normalizing stuff. For example, for an input of a ramp, which would be a very classical example. Then I often use this to change the contrast of something. And as you've seen, there are alternatives to that. For example, EFIT, which will not clamp the values that come out of it, but extrapolate them. And also, if you really care, some people use the power function for that. I don't like it, but that's a possibility. And then the third thing is basically you change the expected result of something. For example, of a random. So those are, if I would have to roughly categorize the most use cases for fit, I would say those 3 are what I use it for the most. And as you can see, this is why it deserves its own video, because the fit function is pretty important. Okay, so I hope this is helpful as a couple of additional thoughts to this. So thanks very much and see you later. Cheers.